welcome everybody. I'm Daren Starnes, and I am currently sitting in my classroom at the Lawrenceville School, having just enjoyed our very first truly spring day and 75-degree weather.
And this is Josh. I'm sitting at my house in Tucson, Arizona, having just enjoyed my first summer-like day. About 95 degrees here in Tucson.
And we're really glad that you're joining us. We understand there may be a few students on board, so I wondered if we could test out this software. Those of you that have students watching, would you mind just raising your hand? There's a little hand icon next to a check mark there. Just curious to see what we've got out there in terms of students. Oh, we've got a few clicks out there. Great. Well, welcome to everyone. We're going to jump right in, and I'm going to turn off my camera so that we don't get any kind of interference with the PowerPoint. As Nicole said, we'll stop for some questions when we get through the first 5 tips, and then we'll take questions again at the end. So feel free to type those in. So our title today is the Top 10 Tips for Excelling on the AP Statistics Exam. Both Josh and I have been heavily involved in the grading of the exam for quite a few years now. And most recently, we've been leading individual questions on the exam as they've been scored. So I'm going to start off with number 10. One of the most important things that you have to realize in statistics is that you're speaking a very special language. So my first tip is for the students. You got to talk the talk on this exam. And by that I mean you have to use the language of statistics very carefully, very precisely. The AP exam readers are required in most of the rubrics to deduct credit for any misuse of a term. So if you're using any of the terms that are defined in your textbook or on the AP statistics syllabus, you need to use them correctly. Here are a few examples. A number of students tend to throw around words like confounding or biased or skewed in more everyday language, but they don't mean them in their technical statistical sense. When the reader sees those words, they're trained to read them exactly as they're written. So another couple of examples have to do with distinguishing blocking in experiments from stratified sampling. I know we've both seen those terms used interchangeably when they shouldn't be. And being very careful with use of the word normal. A normal distribution is a very special bell-shaped curve that has some nice properties. But in many cases, the problem really just requires students to think about whether the distribution they're talking about is approximately normal. So it's important to get across the ideas that you want to share as a student in your own words, more so than.
How did you get it?
You got a call. You were just there. You weren't listening.
Okay.
We have a couple people not muted there, Nicole.
Fine, I would like some too.
The other thing that you have, besides the language, is your use of notation. So when you are using symbols, you have to use those correctly too. A couple of common examples. When students are talking about means, sometimes they unfortunately use the notation like p or p hat, which really means they're talking about a proportion. Or another common example is using mu instead of x bar or vice versa. So it's really important to be confident about the symbols that you're using. The formula sheet provides correct symbols for the mean and for the proportion, but sometimes it's easier just to write MEAN when you want to clarify that you mean mean. Our advice in summarizing, you got to talk the talk. First of all, make sure you're comfortable with the vocabulary and with the notation. Then you don't have to worry about these things. You can use them like a really well-trained statistician. And the other is to only use terms and symbols you know. It's better to explain in your own words than to use a term or a symbol incorrectly. So that's tip number 10. You got to talk the talk. Josh, over to you.
Well, I think we got one more on the advice. Is that?
Apparently, we have one more on the advice. So when you're showing work, we recommend that you start with the numbers substituted into the formulas. We don't recommend showing the symbolic formula with things like p hat and x bar and mu sub p hat because it's way too easy to make a notation mistake. And if you see above, a notation mistake means that the reader often has to deduct credit for that. Sorry about that. Here you go, Josh.
All right, so number 9 is, we've titled this one, Know the Score. And this is a lot about the structure of the exam and how the scores are put together to reach an overall total. So it's 2 parts. Multiple choice is worth 50 points possible, so half of the total exam possible. You get 1.25 points for each correct answer. Basically, there's 40 questions. It gets scaled to 50 by multiplying by 1.25. And you want to answer all the questions. Unlike some exams, like the current SAT, there's no penalty for guessing. In some exams, you might lose a quarter point or something like that for every wrong answer. But that's not the case with AP Statistics. You want to answer every single question. There's no penalty for guessing at all. The free response is also worth 50 points, half the grade. And it's divided into 2 parts. Well, actually, backing up for a second, it's 0 to 4 on each question. And there are integer scores, so you get a 0, 1, 2, 3, or 4. The questions 1 through 5 are intended to be a little bit shorter, and they're each multiplied by 1.875 to get a total of 37.5 points for questions 1 through 5 together. Question 6 is a different animal. It's called the investigative task, and we'll talk more about that later. It's worth more than any question on the exam. By itself, it's worth 1/8 of the entire test score. So you want to make sure and give some good attention to question 6. Then, what students always ask me is, how well do I need to do to get a certain grade on the exam? How many points do I need to get a 5, or how many points do I need to get a 3? So we have an example for 2012. If you got 70 out of 100, that resulted in a 5. 57 out of 100 resulted in a 4. 44 out of 100 gave you a 3, and 33 out of 100 gave you a 2. Now, those distributions will change from year to year because exams are harder. Some exams are harder, some exams are easier. I just gave my students a practice exam from 2007 where the cutoff for a 5 was a 63. So that was comparatively a harder exam. The main message for both teachers and students, what you want to convey, is that the AP exam is harder than a typical classroom test. It covers, obviously, the entire year, and there's also a variety of questions. Some are easy, some are medium, and some are deliberately challenging. So you don't want to stress out over a question or two, even if it's a free response question. If a student misses part B or knows that they can't do part C on a question, it's definitely not the end of the world. There's a lot of room for missing questions here and there and still getting a really high score on the AP exam. So don't stress out. Know that in a typical year, 70 or 75 is going to get you a 5. 40, 45 points out of 100 is going to get you a 3. Knowing that, hopefully, will relieve some anxiety for students while they're taking the test. All right, Daren, up to you for number 8.
Number 8 has to do with pacing yourself. On the multiple choice section, you'll have 40 questions and 90 minutes. So that leaves 2 minutes per question and an additional 10 minutes to check your work, go back and look at questions that you may have skipped initially so that you'll have, I think, ample time on this section of the test. Many of my students are able to finish a little bit early, even as they go back and check work and reread questions that they weren't sure about in the first place. Most important advice is not spend too long on any one question. Although it's generally true that the questions get slightly harder as you move forward towards number 40, it's not strictly true. So you may find question 38 challenging, but then question 39 is something that is really comfortable. So they're all worth the same amount. It's not worth spending 5 minutes struggling on one question that might cost you 2 other questions that you're really comfortable with. As I mentioned, the questions do generally get harder towards the end, so it might not be too surprising to find a couple of questions in the 30 to 40 range that are challenging that you might want to take a look at and decide whether to skip on the first pass. For the multiple choice section, usually the pacing is reasonably good if you don't get bogged down on a question. The free response section is a little bit different story again. Josh mentioned that there really are 2 pieces to the free response section, questions 1 through 5, and then the investigative task. All told, you've got 90 minutes to complete this, but it's really important. Question 6 counts for 1/8 of the total exam score, not to run out of time there. So a little bit of additional information on that investigative task. It's important that students know that question 6 is going to ask them to do something they've never done before. The questions are really cleverly written so that they may start out with something that students have seen and then build on that and gradually move outside the box. What I find really interesting is that some of my students who might not be able to answer one of questions 1 through 5 successfully can often make really good progress on question 6 because they're just creative thinkers. I know there are times when some of my students have outscored me on question 6 because I kind of know the basic techniques really well, but then get encumbered by trying to think in a new way. So I think these are really fun problems to try. They are going to require some creative thinking to be able to get a 4, but it's very doable for students to be able to earn at least a 2 on this question if they just attack it in the way that the question is organized. My advice to my students is always to start with questions they feel confident about. So I'll have them look at questions 1 through 5, and at this point in the year, they know their strengths and weaknesses pretty well. So they will gravitate towards usually question 1 because it's meant to be fairly accessible to everyone on the exam to get everyone off to a good start. And then 2 or so of the other 4 questions, maybe they're really comfortable with questions about normal distributions, and there's maybe they'll see a question about that. My students tend to actually really like hypothesis testing and confidence intervals because we've done them for quite a while now, and so they'll tend to gravitate toward those. Some of my students really enjoy the questions about surveys and experiments, and when they see that question, they'll go attack that one. But none of my students will save question 6 until the end. That's something we've worked really deliberately on. It is possible that if you get bogged down in a question on the free response section, you will run out of time. So if you're going to run out of time, you don't want to run out of time before the one that counts 1/8 of the free response score. So free advice, start with question 1, but don't feel obliged to work in a linear order after that. It's usually pretty straightforward. Hey, Josh, over to 7.
All right. I wanted to add one thing to the pacing issue, and that is I had a teacher in a workshop who told me a story about how he had a student that was quietly waiting for the proctor to tell him to move on to question 6 after he finished questions 1 through 5 because there's a new set of directions for question 6. Even though it's the same instructions, it's sort of designated separately. And then the proctor said, time is up, and then, he didn't have time to do question 6 at all. So let your students know that in the layout of the exam, there's sort of a new heading and a new set of directions for question 6, but they're allowed to go in any order. And definitely don't save question 6 till the end. All right, so now on to number 7, which is be smart with technology. The first tip is to not type data in just because it's there. I've been talking with my students about this a lot recently, that a lot of times they'll provide the data, but then they'll also give summary statistics like the means and standard deviations or the equation of a least squares regression line. And in many cases, they don't actually need to use the raw data. They can use the other information provided. A follow-up to that is that if they do provide both the raw data and the summary statistics, you can use those summary statistics as a double check to make sure that you've typed in the raw data correctly. That's a nice way to use that information if you do need to type in the data. The next big issue, and this is one that comes up a lot on the AP teachers community, is how to address the use of the calculator on the exam. And so there's a range of opinions and there's a range of strategies that teachers use both in their class and on the AP exam. So for now, what I'm speaking to is how things work on the AP exam. You may or may not make different choices, throughout the year in your classroom. But the bottom line for calculator notation, or what we call calculator speak, is calculator speak alone will not get you full credit. There's an example there with a binomial distribution. Typing in binom PDF 12, 0.2, 3 will not earn full credit. And what I tell my students is they need to imagine that the person grading their exam is a 60-year-old college professor who uses a computer and has never once picked up a graphing calculator. And although the grader would probably be able to figure out what each of those numbers means, it's really the job of the student or the responsibility of the student to clearly communicate the method. So if they can imagine that they're talking to somebody that's never used a graphing calculator before, they'll realize that that first line there isn't sufficient for good communication. So instead, we'd recommend either using the binomial formula, which you see 12, choose 3, and so on, or using the calculator command, but annotating your entries. Like, instead of just putting 12, put n equals 12, and p equals 0.2, and k equals 3. Those are standard statistical symbols and notation. And then, whether or not you've used a graphing calculator before, you know exactly the parameters of that distribution. The same thing would be true with number 2. The example of number 2 with normal CDF. My students love using normal CDF, especially when they're going between two boundaries like this example. It saves a lot of time. But if they just put normal CDF 90, 105, 100, 5, that will not result in full credit, even if they get the answer correct, because again, it's not good communication. So instead, students can find the z-score, draw, shade, and label a normal curve, and then find the area using the table or using normal CDF. Or they can use the normal CDF command as long as the entries are annotated. So instead of just putting 90, 105, they put lower bound equals 90, upper bound equals 105, mean equals 100, and standard deviation equals 5. Now I want to piggyback for just a second on something that Daren mentioned in passing a few slides ago, and that is the difficulty of using symbols correctly. So we know that there's lots of different standard deviations that show up in our course. It could be the standard deviation of the data, of a sample, could be the standard deviation of a population, it could be the standard deviation of the sampling distribution of X bar, and all of those have different symbols. So I have my students, instead of trying to pick the right symbol, just write out the word mean, and write out, SD or STD, DEV for standard deviation. And so they're not putting themselves out there and possibly using an incorrect symbol. So the summary of this is it's perfectly okay to use technology as long as it's clearly communicated so that somebody who is not familiar with the graphing calculator will be able to understand what the student is doing. All right, on to number 6.
All right, tip number 6. This refers specifically to inference questions on the free response section. So whether you're calculating a confidence interval or performing a significance test, we strongly encourage that you follow the 4-step inference process when writing up solutions. So we've made a copy of the 4-step inference plan for both confidence intervals and tests. And this is from our long experience working with the rubrics for scoring these problems. In any significance test rubric, there are going to be 4 elements that the grader is going to be looking for. We've chosen to call them state, plan, do, and conclude. But in the state part, the grader is going to want to see the hypotheses carefully stated. Any of the parameters that are used there need to be correctly labeled. So mu for population mean, p for population proportion. And in some cases, the question will require a definition of the parameter. So the mu or the p has to be carefully explained. Then in the plan step, the expectation is that the inference procedure will be named. So one sample t-test, for example. It's also possible to identify the inference method by giving the formula for that method as part of the calculations. But at some place in the solution, the inference method has to be identified. And also as part of the plan step, the conditions for using that inference procedure need to be clearly identified and checked using the information provided in the problem. So for instance, if you're wanting to do a one sample t-test, then it's important to check that the data came from a random sample or a randomized experiment of some kind, and also to check the normal large sample condition. So you need to either have normally distributed population or large sample size. In the do step, students can do one of two things. They can show the numbers substituted into the formula to get the test statistic, or use the calculator stat test menu to get the test statistic. And the p-value can also be obtained through the stat test menu. So it's absolutely legitimate to write down the test statistic and p-value from the calculator, and any degrees of freedom if those are appropriate for that problem. The advantage to showing the work inside the formula, put the numbers in the formula, is that some partial credit could be available then. If you only use stat test, then it's either an all or nothing proposition if you put information into your calculator and then write down the test statistic and p-value. It's either right or wrong. So to be honest, I encourage my students to use stat tests. I think they're more effective that way. They're more likely to get it correct on a consistent basis, down to occasional typos. And then in the conclude step, we're looking for a clear decision about the null hypothesis. So either reject or fail to reject the null based on the calculations that were done, that clearly links the p-value to a significance level. So hopefully the significance level has been stated at the beginning, and now we're just comparing that p-value to the significance level and making a decision. And then some contextual conclusion that talks about the strength of evidence for the alternative hypothesis. So it's really two distinct sentences if my students are writing it. The first one has to do with whether they reject or fail to reject the null hypothesis based on how their p-value compares to their alpha level. And the second sentence is about whether they do or don't have convincing evidence for the alternative hypothesis written in context. The confidence interval side is a little bit easier because there are no hypotheses. So we're just thinking about what we're going to estimate and at what confidence level. So a clear statement of the parameter really helps students get a good contextual conclusion at the end of the problem. The plan step is the same as I mentioned before, and the calculations are the same as I mentioned before. You can use stat tests or stat intervals, depending on the calculator, to do the do step, but the risk is it's an all or nothing proposition. Again, I want to recommend that writing out the symbolic formula with, for example, x bar plus or minus t star times s over root n is really risky. My students tend to make notation errors, and then the grader has to do, as I said earlier, and do a mandatory deduction. Another suggestion related to this four-step process, because the grading rubrics are set up this way, it makes it easier on the grader if the student labels what they're doing in each of these steps. So something like hypotheses, conditions, calculations, and interpretation, or state, plan, do, conclude, is much appreciated by the grader. It makes it easier for them to match the solution to the grading rubric. And I think quite often students who organize their work in this way tend to perform fairly well. It's a safe bet that at least one pre-response question will require the entire four-step process. And it's possible that there might be a second one on some exams. So I don't have a crystal ball. I don't know what will happen this year, but I'm at least 99% confident that one problem will require a full four-step inference problem. There's a wonderful little inference review at Larry Green's website, Lake Tahoe Community College. So I'm just going to try to launch that link, and then in just a second we're going to be taking some questions. So this is Larry Green's website at Lake Tahoe Community College. It's a wonderful opportunity to practice identifying which is the correct inference method from among all the ones we've studied this year. So from this site, if you click on Select All, and then deselect one-way analysis of variance, and deselect predictions for a single value of y for a fixed x, those are two that we don't really cover in detail or at all in the AP Statistics course. And then once you've chosen your options, you just click Submit, and some kind of research question will come at the top box. So this one's interesting. Do college students listen to the same radio stations as the general public? 2,000 college students were asked what radio station they listened to. Their choices were compared to the known overall rating. So this is a little bit vague, and deliberately so, to have students think about what kind of procedure is being asked for. What I like is it, first of all, forces the decision between a confidence interval and a hypothesis test. So the question is, are we trying to estimate something, or are we trying to test a claim about something? And the wording in the first sentence here seems to suggest testing a claim about whether college students listen to the same radio stations as the general public. That doesn't sound like an estimation question. So I'm thinking test. And then we have to identify what type of test. Is it a test about a mean, a test about a proportion, a test about a difference between two parameters, or possibly a chi-square test that has to do with distribution of categorical variables or relationship between categorical variables. So my reading of this sounds like we're talking about the distribution of a categorical variable, which is radio station preference or primary radio station you listen to, and then we're looking at the distribution of listening preferences among college students. So I'm going to try and guess something here just so you can see the feedback. Oh, good for me. It's always risky when you do one live and cold that you might miss it, but you do get immediate feedback, and if you get it wrong, you actually get a hint to get you back on the right track. So suppose I picked the wrong kind of chi-square test. You see the feedback from me face, and then we can get a little hint here about testing for a distribution, not independence. So good job, we got it right. Okay, at this point, I think we're going to offer up some questions, Nicole.
Great. We do have a lot of questions that came in while you guys were talking, so I will start with those. If anyone has more questions, feel free to send me a message using the chat, not the Q&A. So the first is from Jan A., and it is, can you explain the difference in blocking and stratified sampling? What are the correct definitions?
Okay, this is Josh. Basically, stratified sampling happens when you are selecting a random sample from a population, when your goal is to estimate some characteristic of a population. Blocking happens when you're assigning treatments in an experiment. And that's the key difference is stratified is a technique that you can use when you're doing a sample, and blocking is a technique that you can use when you're assigning treatments in an experiment. They have a lot of the same benefits, and they sound very similar because you start by forming groups that have some characteristic that you think is going to be related to what you're measuring. But again, stratified happens when you're sampling, and blocking happens when you're doing an experiment. Okay?
Thank you. The next one is, if you show the symbolic formula while answering a question, do you have to explicitly name the formula?
No.
Okay.
Agreed.
The next question is, on the free response, on average, how many concepts are on each question, since the exam is covering the course as a whole?
That's a good question. I'm not sure that there's an easy answer for it. I know that when I was on the test development committee, we are very conscious of trying to match the percentages that are in the course description. Things that say like collecting data should be 10 to 15%. So we made sure that, no more than essentially one full item was about collecting data. Inference, on the other hand, was 30 to 40%. So we'd keep careful track, even if questions were split, maybe one part on question 1 and 2 parts on question 2. We kind of add those up to make sure that they fit within those guidelines. But inference, there's a lot of inference, right? That's 5 chapters in the book. So it could be that there might be a, one sample t interval for a mean and then a chi-square test. And we never do anything with z-test for proportions. It's just hard to know. On the multiple choice, though, of course, with 40 questions, they are able to get a lot better coverage of the entire content. So I know that wasn't an exact answer to your question, but hopefully it helps a little bit.
Thank you. The next question is from Jeff C. I always tell my students to show the work for the test statistic when conducting a hypothesis test. Yet every FR rubric indicates the student only needs to name the test or show the formula, then give the test statistics and p-value. Is there any advantage to showing the work for the test statistic? Will a student lose points for a formula shown with wrong values, but the right test statistic and p-value?
Sounded like a multi-part question, very spirited. So there is a potential advantage to showing numbers substituted into the test statistic formula, and that is if the numbers substituted into the formula make for a correct formula for the test statistic, that's going to probably be at least partial credit. If there's then a computation error on the test statistic, then we're still at partial credit. If the student does not show any work at all and just goes to stat tests and provides the wrong test statistic and wrong p-value, there's really no credit there. There's no way for the grader to have any idea probably what the student did. So I think the other part of the question was if a student shows a formula with numbers substituted in and the formula is not right, well, that's going to have to count off. So if the student gives a correct test statistic and p-value from the calculator, we're sitting with full credit for the do step. But if the student then provides a formulaic attempt to support that, and the numbers are plugged in and it's not equivalent, then it sounds like we can't have full credit. Josh, would you agree?
Yeah, I absolutely agree. And what I do with my students during the year is different than the advice I'd give right now. I found that very few of my students make typos, but lots more of my students have trouble executing the formulas correctly and getting everything done that way. So my strong recommendation to my students at this time of year is to use the stat test menu for the test statistic and the p-value, or the endpoints of a confidence interval, if it's a confidence interval question. Understanding that there's a risk of a typo leading to no credit, that's a much smaller risk for my students than the risk of trying to do it by hand and then messing up somehow or coming up with an answer that disagrees with the calculator answer.
Nicole, I'm sort of keeping an eye on the clock. I wonder if we should maybe do a few more slides and then we can do one more batch of questions at the end.
Sure. We do have 2, 3, 4, 5, 6. We've got 7 questions on tap. So.
Okay. Then we should definitely move on, I think.
Okay.
And if people want to sign off before at the end of the slides, that's fine, or they can stick around and listen to the questions also.
Perfect.
All right. So number 5, actually, we've kind of talked about half of them. It's a naked answer equals no credit. So I'm not sure where that phrase came from exactly, but what we're talking about here is an answer with no supporting work. And so we wanted to quote you. These are the directions that students are supposed to read at the beginning of the free response section. It says, show all your work, indicate clearly the methods you use, because you'll be graded on the correctness of your methods, as well as on the accuracy and completeness of your results and explanations. And this is really true. We hold students to this. The problem, or the most common time when this comes up as an issue, is on probability questions, where students can maybe do something either in their head or on their calculator, and they'll get an answer, they'll write it down without any supporting work. And at best, that's given partial credit. Okay? There is a slight exception to the rule, and that's what we've just been talking about. This question about using your stat test menu for inference questions for the do step, the p-value and test statistic, or the endpoints of the confidence interval. I put exception in quotes because it's not really a violation of this, because students in the previous step, the plan step as we call it, will have identified the procedure as, say, a 2-sample t-test or a 1-sample z-interval for a proportion or something like that. So that identification of the process is the work, is the justification for the method. And then you're just reporting the values from your calculator at that point. We've talked about the potential drawbacks, and I just wanted to add one more thing on, and that is when I'm teaching this during the year, when we're going one chapter at a time, I prefer to have kids, work with the formulas so they get some practice, so they know how they're developed, and also so they're able to handle multiple choice questions that may focus on aspects of the formula for the test statistic or the confidence interval. All right, let's move on to number 4.
This is a common theme that my students and I talk about leading into the exam. And, many of the questions on the AP exam, students are forced to decide between which of 3 distributions are being talked about at any moment. One is the distribution of sample data. That could be quantitative data. We might be looking at a dot plot of some sample data, or it could be categorical data, and we're looking at a bar chart of some kind. Or the problem could be talking about the population distribution of some variable. And again, that variable could be categorical. So the population distribution could consist of the percent in each category, or it could be a quantitative variable. So the population distribution we could imagine might be a normal distribution. Or we could be talking about the sampling distribution of a statistic, like X bar or P hat. So that is the value of the statistic in all possible samples of the same size taken from the population. And often the sampling distribution of the statistic follows a nice normal distribution pattern approximately if certain conditions are met. So distinguishing between these 3 distributions is difficult. You have to read really carefully to see what the question is asking. But here's one example from a recent exam. Big Town Fisheries recently stocked a new lake in a city park with 2,000 fish of various sizes. The distribution of the lengths of these fish is approximately normal. Timeout. Which distribution are we talking about? Well, it sounds to me like that's all the fish. I think we're talking about the population distribution of length being a quantitative variable. And we're told that it has approximately a normal distribution. Now let's look at part A of the question. Big Town Fisheries claims that the mean length of the fish is 8 inches. So that's a claim about the population mean, mu. If the claim is true, which of the following would be more likely? A random sample of 15 fish having a mean length that is greater than 10 inches. A random sample of 50 fish having a mean length that is greater than 10 inches. Justify your answer. So this one is the tricky one. We're hearing something about a random sample, so we might be thinking about the distribution of the sample data for those 15 fish, which could be a dot plot, for example, and the same for the random sample of 50 fish. But to answer the question, we need to know how the sample means would vary in random samples of size 15, and how the sample mean would vary in random samples of size 50. So this is actually a question about the distribution of sample mean. And you can see from the scoring guide that the part A is scored essentially correct if the student says that the sample of 15 fish is more likely to have a mean length that's greater than 10 because it's there's going to be much more variability in sample means for samples of size 15 than for samples of size 50. Or put another way, you're more likely to get closer to the truth about the mean length of the fish if you take a larger random sample than if you take a smaller one. So you can see the justification in this problem has to be based on the variability in the sampling distribution of X bar. So all the elements are shown really nicely in this question, and I would say that on each year's exam, you're going to find at least one question like that. Okay, Josh, I think we're on to number 3.
All right, number 3 is don't write too much. This is an interesting contrast to number 5, which was make sure to justify your answer and show work and communicate. There's a fine line to be drawn between saying enough and not saying too much. So the first tip is less is more, and that is the best answers actually tend to be quite short and to the point. You don't need to go on and on. I think there's a belief that a lot of students have from their other classes, maybe an English class or a history class, that they need to write as much as possible and just dump their brains out onto the paper. That's definitely not true here. And as we've talked about, if you go on and say things that are incorrect and contradictory, you'll lose points. Okay. So the second tip, says to answer the question in context and then shut up. Be quiet. So many kids lose credit because they just keep going on, and we say in the trainings, now had they stopped after the first sentence, they would have scored E. But if we continue reading, we'll find out, and then the scores go down. The third point is that space provided on the exam is typically more than enough. There is careful thought to how the questions are laid out on the page and where parts start and where parts end. Students can use that as a rough guide, but they're almost never intended to fill the entire space. The fourth one is to avoid parallel solutions. And we've kind of referred to this already, but the idea is that students will be graded based on the weakest of their responses. So if they attempt to answer a question two different ways, for example, using their calculator and using a formula, students will be graded on the weakest response. That way we discourage kids from just trying thousands of different methods, hoping that one of them is correct. The next point, don't interpret the p-value or the confidence level unless asked to. We find that, as perhaps as good teaching during the year, teachers will reinforce, asking students to interpret the p-value or interpret the confidence level just as sort of regular practice. But that's not part of the four-step process that's required for typical inference questions. By interpreting the p-value, I mean something like, assuming the null hypothesis is true, there's a such and such probability of getting results like ours or more extreme by chance alone. Or the confidence level would be if we did lots and lots of random samples of this size and computed lots and lots of intervals from those samples, about 95% of the intervals would capture the true parameter. Those are good interpretations that students should be ready to do if they're asked to, but they shouldn't volunteer those as part of a regular inference question because students honestly mess them up quite easily, and that will lower their score. The last one is to not argue with the test writers. Believe what they tell you. So if they say the conditions are met, say thank you in your head and just move on. Or if they say that everybody is going to respond to the survey, even though that may not be true in real life, if they tell you everybody will respond in the survey, then just believe it. They're trying to make it easier for the students. So don't argue with the question writers. All right, that's number 3.
Speaking of the questions, this is one of my simplest pieces of advice that I use with my students all year long. Often when I give papers back, they'll have a little acronym, RTQ or ATQ. RTQ simply means read the question. Sometimes if you don't read very carefully, you go off in a different direction than what was intended. And my other favorite is ATQ, answer the question. It's amazing how many times we look at a response on the free response section and the student didn't actually answer the question that was asked. They may have answered a different question that was pretty interesting, but we can only give credit to answers that head toward the one that we were expecting. So if a question asks you to do each of the following, make sure you, so for example, if a question asks you to describe a distribution of a quantitative variable, they're expecting a discussion of shape, center, and spread. That's a prompt that students should know by the end of the course. If the question asks that students compare distributions, then it needs to be comparative about the center, which one has a higher or lower center, which distribution has more or less variability than the other. The question asks you to describe similarities and differences, then that's what's expected. All of these have appeared on different exams And in each case, I've seen students follow one of the other sets of directions besides the one that was given. If a question asks you to explain or justify, then obviously that's something that you're going to need to do to get full credit. And this is the trickiest one. If a question is a compound question that asks you to do more than one thing, for example, find the mean and the standard deviation of a random variable, or calculate and interpret a confidence interval, the student has to do both things in order to get full credit. So it's really important that you read the question carefully and then be sure that you've answered the question that was asked. If it's a yes/no question, then you need a yes or a no, and you need justification. Okay, Josh, number one.
Number one, be prepared. So one thing you could do to be prepared, review the formula sheet and the tables that come on the AP exam. I find my students do use the tables. Lots of times they don't use the formula sheet, but it's good to know what's on the formula sheet so that if there is an issue, you can go look at it, and maybe looking at the formula sheet will help prompt you and trigger something in your brain. So know what's on the formula sheet, know what the formulas refer to, and know how to use the tables that are provided. And just so you know, the formulas and the tables are provided on both sections of the exam, the free response and the multiple choice. Okay. The next tip is to do lots of practice AP exam questions, including, as you'll see, a full-length exam if possible. It's nice for students to have the experience of sitting for a 3-hour statistics test, to have to stretch their brain for that length of time and covering the entire course. And if you have an opportunity to do that, it'd be nice to focus on more recent exams. You can find in your AP audit account recent exams that have been given internationally. These exams, of course, are secure, but you can use those with your students in class. You can also assign released free response questions from AP Central to your students. And as a general rule, I'd recommend that you focus on more recent exams. There are, of course, good questions on older exams, but the more recent exams will be better indications of the kinds of questions that are being asked, and the scoring guidelines will be more reflective of how questions are being scored nowadays also. The third thing is to identify weak spots and focus on them. So there's a couple ways to do this. One, of course, is the full-length practice exam that covers the entire content. You can tell by the kinds of questions that your students are asking after that, or if you grade it yourself, you can see where the weak spots are and focus on them. Also for teachers, after the AP exam and after the scores are released in July, maybe sometime in August or September, you'll be able to get an instructional planning report that talks about how your students did in each of the 4 major content areas: descriptive statistics, collecting data, probability, and inference. I know my students typically are weak in probability, so we'll do lots of extra practice questions about probability leading up to the AP exam. And then the last thing for preparing students is to give them a set of flashcards that we have available in the teacher's resource materials for both TPS 4E and 5E. For TPS 4E users, they're in the binder at the very back. For 5E users, there's no print binder anymore, but if you have the teacher's resource flash drive, if you look in the Chapter 12 folder for the teacher's resource materials, you'll see a PDF of the flashcards there. There's a set of 80 flashcards that review all the key ideas from the course. Every year, my students report back to me that they were very glad that they went over the flashcards as they were getting ready for the AP exam, because several of the concepts that they had been reviewing showed up on the exam, and they felt much better prepared because of that. All right, so that's number one. So we'll go ahead and count down the top 10 tips again. You can see them flashing up there on their screen. And the very last note is for questions. So, Nicole, you can go ahead and read out some of the questions that have come in.
Great. So we do have a lot of questions that have come in. The first is from Jan A. What about using panic for confidence intervals and phantoms for hypothesis testing as a guide? And for those of you that don't know, panic is parameter assumption same test interval, conclusion. And SPANAMS is parameter, hypothesis, assumptions, name test, test statistics, obtain p-value, make decision, state conclusion.
This is Josh. I think that's a fine thing to do if that helps your students. I prefer our four-step state plan do conclude. I find that students, when we look at rubrics or scoring guidelines, they find it very reassuring that the 4 steps I've been teaching them match up with the 4 steps that are being assessed on the rubric. But that being said, numbers of students use those PANIC and PHANTOMS acronyms as a way to organize their answers and to remember the steps. So I think, if it works for the students and they can answer the question successfully, that's fine.
I have to be careful on this one. My colleague who teaches AP statistics next door to me uses those 2 acronyms with her students. So although the state plan do and conclude is my favorite, the other acronym seems to work pretty well for her students.
Next question.
Next question is again from Jan A. Sometimes in the book, and she's using TPS 3E, the assumptions aren't really met yet. So I tell students to do the calculations anyway. But what should they say in the free response section to note that assumptions may not be met?
We have good news for you there. If the question on the free response section asks the student to calculate a confidence interval or perform a hypothesis test, the good news is that the conditions are going to be met. So students don't need to worry about that. If they're actually asked to do calculations, they'll be provided with either reassurance that the conditions are met, or they'll be given the appropriate information to verify that they really are met. It is possible that there'll be a question somewhere on the exam that focuses in on a situation where we're just checking conditions, and in that case, the conditions may or may not be satisfied. But in a free response question where students are asked to do the 4-step process, the conditions will be met.
I agree. Next question.
The next question is from Steve C. My students want to know if anything has changed for this year's exam by way of grading or content.
Not that I'm aware of. They certainly haven't made any announcements on the AP teachers community or on AP Central, so everything is the same as last year and the last several years.
I agree.
The next question is from John P. For listing the inference method in the 4-step process, is it enough to list what function on the stat test menu of the calculator was used? I am thinking no, but I feel like my students have gotten into that habit.
Yes, it is enough. That's sufficient. To call it 2-SAMP t-test or 2-prop z-test is sufficient for identifying the procedure.
Yeah, I would agree. The only follow-up I would add is that's on the weak side of communication. It would get credit, but if a student was, at a 2.5 or a 1.5, and a grader had to make a decision about whether to take that 2.5 up to a 3 or take that 2.5 and move it down to a 2, very minimal communication usually is not a point in the favor of the student. So it is sufficient, but if you can encourage them to write it out, maybe with a more complete name, that would be helpful. Okay, next question.
The next question is from Tony S. Are students required to use a pencil or can they use a pen on the AP exam? Is one preferred over the other, especially on the free response? Different AP exams tend to require different types of writing instruments.
Yeah, good question. Certainly on the multiple choice, kids use pencil. And on the free response, I'm not sure if there's an official requirement, but I'd say 99% of kids are using pencil on the papers that we see. So I'd recommend pencil.
The next question is from Amit B. can you give a good way to explain the difference between lurking variables and confounding? And what is the best way to explain what R upper caret 2 represents?
I'll take the first one.
Okay, I'll do the second one.
My best advice is not to use the term lurking variable at all on the exam. It's not a commonly agreed upon term out in the statistical community. And in fact, those of you who are using the 5th edition of our book will notice the disappearance of that term. It's been a term that's been around for a while, and certainly it means more than one thing depending on who you ask. So I sort of prefer to call those things other variables rather than coming up with a fancy name to them. So other variables besides, say, the explanatory variable or the response variable is a much safer term that would be accepted by anyone. The term confounding is definitely on the AP Statistics topic outline, and it's one that if you're going to use, you need to understand that for there to be confounding, the relationship between the explanatory variable and the response variable has to be blurred by this other variable. And I'm not going to use that L word, but the other variable has to be associated with the explanatory variable, and also it has to have some clear relationship to the response variable. So confounding is a complicated situation where another variable is linked to the value of the explanatory variable and also clearly has a relationship with the response variable.
So this is Josh now. These are two of the issues, the idea of confounding and the interpretation of R squared, that my students find the hardest, and on at the grading, we find that students typically do the weakest. So very valid questions. So R squared it usually arises when we're talking about regression, and basically R squared is trying to answer the question, how much better will my predictions be if I'm allowed to use the X variable along with the least squares regression line compared to not being able to use the X variable. So we have an example now in the 5th edition where we try to predict the price of a used truck based on the number of miles that it's been driven. And so I tell my students, well, suppose you just see a truck driving down the road and you see a for sale sign in the window, but you have no idea how many miles it's been driven. You can still predict how much it would cost. You would just use the average cost of all the used trucks that you have. But that prediction would not be very good. You know that you could make a better prediction if you knew how many miles it had been driven. So you could make a scatter plot then with number of miles on the x-axis and price on the y-axis and fit a least squares regression line and make better predictions. So R squared essentially measures how much smaller the sum of the squared residuals are when you get to use the least squares regression line compared to just using the average value of y. And since it's a percentage, so if R squared is, say, 38%, that means the sum of the squared residuals are 38% smaller when you're using the least squares line compared to just guessing the average value of y. So that's the long explanation that I try to give my students to help them make sense of it. The standard interpretation that you'll hear is really just an abbreviated version of that, and they'll say something like 38% of the variability in price is accounted for by the least squares line using x equals miles. And that's basically a statistician's shorthand that often doesn't carry much meaning for students. So I like to make sure they understand the longer explanation or the longer story, but I make sure to expose them to the sort of abbreviated interpretation also, because I've seen that used in both free response questions and multiple choice questions. All right.
So this is Daren again. I just want to acknowledge that we've reached the 1 hour mark on our webinar, and I know Josh and I are very happy to stay and continue answering some questions, but we also understand if people have other plans, and we're still recording the webinar, so don't worry that you'll miss something. You can always play it tomorrow once the call uploads the link. But I wanted to take a moment to thank everybody for joining us and hope that you've gotten a lot out of it. And as I say, we'll be glad to stay and take more questions.
Absolutely.
Great. We have about 8 questions left on tap, and if anyone has any more, you can send them to me using the chat function. And I want to thank you guys again for joining us tonight. So the next question is from Mary B., and this is from her students. What concepts are most frequent on the exam? What is the balance between conceptual questions versus skill-based questions on the multiple choice?
Could you repeat the last part of the question, Nicole?
Sure. What is the balance between conceptual questions versus skill-based questions on the multiple choice?
Okay. On the multiple choice, I think that there's a real effort to ask conceptual questions. There's no questions that, for instance, would say, here's 8 numbers, find the median, which I would call a skill-based question that we might ask, at the very beginning of the course. Most of them are conceptual, and my students will tell me that they don't use their calculator very often, especially on the multiple choice section, because, again, most of the questions tend to be conceptual. On the free response, you've probably seen more free response questions. There's a mixture of conceptual and sort of calculation or skill questions, but again, I would say that there's a definite favoritism towards conceptual questions.
The next question actually came from a few people, so I'm just going to paraphrase. How much will penmanship or sloppy handwriting affect your grade? If you have bad penmanship, will readers score you against a little bit worse?
This is Daren. I'll take that one. The answer is we will try our best. When we're at the grading, each reader has a partner, and so if the initial reader can't read the handwriting for whatever reason, they will contact their partner and ask for them to try to read it. If they're both having trouble, then we have someone else in the grading room called the table leader that they can take it to, and the table leader also has a partner. So to be truthful, if the writing is really difficult to read, we'll give it up to 4 attempts just to make sure that we're giving it a fair assessment. And at that point, if none of the 4 people can really make out what's going on, then at that point we really can't spend any more time trying to read it. So 4 attempts is as much as we are able to do, but a good effort is made to try to read each student's answer. So I guess the direct answer to the question is not beautiful handwriting shouldn't really impact the score, but illegible handwriting, so illegible that 4 people aren't able to read it, could definitely impact the score.
I'll add also that spelling doesn't count for the most part. So I know I have a student who has some issues with spelling, and I've assured her that as long as we're pretty clear what word she's trying to spell, that spelling incorrectly is not a big deal.
Don't let the English readers hear you say that. So the next question, we have about 6 left. The next question is from Melissa B. How exactly do you practice rule number 4, which distribution, effectively with your students so that they feel prepared and confident walking into the exam?
This is Josh. I would do exactly what Daren did as he was highlighting the slide, which is as you're reading a question or talking about a scenario, every time that there's mention of a distribution or of some measure of center or variability, that you stop and you say, now which one is it referring to? Okay. Another way that you could do this is to use a couple different applets that we highlight in Chapter 7, which is the sampling distribution chapter. There's one that's, we call it the Rice Online Sampling Distribution Applet. It's not produced by us, but it's really good because on the top it shows a population, on the next level it shows a sample, and then right below that it shows the sampling distribution of a statistic, typically the mean. And really showing all 3 of those distributions on the same screen and then being able to talk about it, I think really helps students begin to clarify which one is which. Daren's going to go look for it right now.
Yeah, go ahead with another question, and I'll find it here in just a second.
Okay. The next question is from Julie C. Inference on the exam. Did I hear you correctly when you said we never do a z-test for proportions?
No. We can do z-tests and z-intervals for proportions. I think the possible a correct statement might be that we don't do a z-test for a mean or a z-interval for a mean. That would only be the case if you knew the population standard deviation sigma, which is almost never the case. So definitely okay to do a z-test for a proportion or a z-test for an interval or a difference, z-test for a proportion or a z-interval for proportion or a difference in proportions. Okay. Looks like Daren's ready to demonstrate the applet.
Yeah, this is the online stat book applet for sampling distribution. You can see that the population distribution at the top is approximately normal or normal looking. And if I take a sample, it'll display the distribution of sample data here, and then it will drop after it takes a sample of size 20. It'll drop the mean down onto this next set of axes here. So if we do a bunch of those, we can get a picture of the distribution of sample mean. But I think the best part is seeing this picture with the population distribution, the distribution of sample data, and then the sampling distribution being built up of X bar.
And you can see that each of those distributions has different spreads and different shapes. Or well, in this case, two of them have normal distribution shapes. So it's always very important that you don't ever say there'll be more variability. You need to say there'll be more variability in the distribution of blank, depending on which distribution you're talking about. So it's getting students to be precise with their language that's the real key here. All right, other questions?
The next one is from Jasmine G. What would a regular inference question that doesn't ask to interpret the p-value or confidence level look like?
So typically the confidence interval questions will start with a statement like, construct and interpret a 95% confidence interval for the mean blah, 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 or the proportion of people who blah, 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 something like that. But it's the construct and interpret that will trigger kids to do the four-step process. And when it says interpret, we're talking about interpreting the confidence interval itself, saying something like, I'm 95% confident that the interval from 2.8 to 3.9, captures the mean GPA for students at our high school or something like that. And for tests, the wording typically will say something like, do these data provide convincing evidence of, or something to that extent, in which case that's a trigger to do the four-step process with a significance test. If it wants students to interpret the p-value, it'll say, interpret the p-value. If it wants them to interpret the confidence level, it'll say, interpret the confidence level, or maybe something like, what does it mean to be 95% confident in this context?
The next question is from Corrine B. Should students be proficient in using the tables, or is knowing the calculator okay?
This is Daren. My students tend to use the calculator more frequently at this point. I have a few students who prefer the table, and they're certainly welcome to use the table throughout the exam. There might be an occasional question in the multiple choice, for example. We've actually run into one very occasionally in a part of a free response where students felt like looking up something on the table was helpful. But for the most part, I would say the majority of my students are comfortable just using their calculators. What about yours, Josh?
For the most part, yes, certainly with normal distribution questions. Where my students tend to use the table more often than the calculator is when they're trying to get a t-critical value for a confidence interval. They'll often feel better with the table because they could just look for the bottom of the table that gives them like 90%, 95%, and so on with the degrees of freedom. But for the most part on inference stuff now, they're using the test menu, which provides that information for them. So that might be more of a multiple choice type of issue where they might use the t-table for a critical value.
All right. We have 5 more questions. This one should be a quick one. Are mechanical pencils allowed on the exam?
Yes.
Okay.
Yeah, I have students ask me that every year. I'm not sure the concern, but my students use them all the time and they've never had any trouble.
Good. The next question is from Becky G. As a follow-up to the penmanship question, how closely is syntax and correct use of English graded? I have a large number of English language learners for whom writing explanations is difficult.
So this is Daren. I work at a boarding school, so I have a number of students who are international students, and this is not the AP English exam. We're concerned about students' statistical knowledge and their ability to communicate their statistical understanding. So unless the structure of the writing gets in the way of that objective, the readers are really going to be forgiving with awkward sentence structure or faulty usage. I can't think of too many cases where I've found that students' use of the English language has gotten in the way, very occasionally though. So I hope that was a clear enough answer.
Yes, and I agree.
Okay. The next question is, what is your recommendation regarding pooling? I have gone with the book answer, but then have seen old free response questions that did pooling.
So pooling generally just means combining data to come up with a better estimate for something. And depending on the situation, pooling is appropriate in some cases and not as appropriate in other cases. So for example, when we're doing a 2-sample z-test for a difference in proportions, the null hypothesis typically says that those 2 proportions are equal to each other. And the calculations in a significance test are always based on the assumption that the null hypothesis is true. So we're left with a situation where we have to assume that those proportions are the same, but we don't know the value of either of them. So that's a case where we do pool the proportions or pool the data, do the total number of successes over the total sample sizes to come up with one estimate for the overall population proportion. In the book, we call that the pooled or the combined proportion. In that case, it's actually not optional. That's what the right procedure is. And for instance, the 2-prop-z test on the calculator automatically does that and doesn't ask students whether they want to pool or not. On the other hand, if you're doing a 2-sample t-test for a difference in means, the null hypothesis is that the 2 means are equal, but there's no statement about the standard deviations needing to be equal. So when your calculator asks you whether you want to pool on the 2-sample t-test, it's asking the student whether they want to combine the data to come up with a single estimate for the standard deviation. That requires that additional assumptions are met, and it typically doesn't add much value or much power, I should say, to the procedure. So the AP Stats answer for anything involving the 2-sample t-test or 2-sample t-interval, when the calculator asks you to pool, just say no.
The next question is from Dion M. Is there going to be a book map again this year? If so, do you know when it will be available?
So Dion, I asked some people at NCTM about this, and they said essentially, not sure, we'll get back to you. But I'm guessing at this point that if we haven't seen a book map for the free response questions, we probably won't. And I'm guessing the reason why is that, well, first, for those who don't know what the question was about, the last 2 years, they've released a book map of the free response questions, which basically gives kids an idea of what each page is going to look like. It'll have a little box that says question is here, and then a blank space where you can, that's where your answer would go. So kids could feel comfortable about the layout of the exam. But what was pretty obvious to most of us last year, when we saw question 5 on the book map, there was a tiny little bit for a question, and then a really long space for an answer. And so we pretty much all knew that was going to be an inference question, requiring the 4-step process. So my guess is that they didn't really think too far ahead on what clues they could be giving with the book map, and have probably stopped that at this point.
The next question is from Julie C. Will students get a deduction if they talk about central limit theorem instead of just using language, large sample size, or does it matter? And what is the cutoff point for N?
This is Daren. We know that students, when they're doing inference about a mean, and they don't know that the population distribution is normal, it's great that they're thinking about the central limit theorem, and that if the sample size is large enough, they're okay to go ahead and perform calculations. As long as students don't start freelancing beyond that, they're probably okay if they just refer to the central limit theorem and the fact that N is large enough. And by large enough, in our text, we use the criterion of N being at least 30. On the AP exam, they usually go quite a bit higher than that, just to be sure that whatever text students are using, the requirements are met. So as long as the student says N is 50, which is greater than or equal to 30, so the central limit theorem applies, no grader is going to object to that. Josh, you agree?
Yeah, I agree. But this is one of those cases where it's possible that saying too much could hurt you. If you use the central limit theorem correctly or refer to it correctly, that's great. But lots of kids will just put the central limit theorem down on any old question, just trying to sound like they know something. And of course, that could end up hurting them.
And the last question that we have is from Lou D. Please comment on the use of bullets in free response questions as compared to full sentences.
Well, I'll go first. This is Daren. I like students using bullets. It helps keep some of my students really well organized. So even within each of the 4 steps of the state plan do and conclude, my students tend to bullet individual parts of those, like test statistic or p-value. The only problem for me is if a question requires students by saying write a few sentences, that's really a case where the bulleted list is going to potentially be problematic. So for the most part, I let students follow their own style, and if the bullets help keep them organized, I'm a fan. And
I would agree as a reader that it's a lot easier to follow the student's work and be able to identify the things that the student is doing correctly if it's well organized. That doesn't necessarily mean bullets, but it does mean well organized. And oftentimes doing it with bullets does help a student organize their response. And so generally that's a good thing.
And one more question just came through from a first-year AP statistics teacher. Is there any general last-minute advice that we didn't cover on today's webinar?
Not really. I think we hit the main points. I would just try to spend as much time as possible going through recent AP exam questions so students feel real comfortable with how they're written, looking at the scoring guidelines to see what kind of expectations they have, and then reminding them that getting 50% on the AP exam is a guaranteed 3, and they don't need to stress out if they're not getting perfect scores.
Yeah, I would agree, and I would also add that there's still plenty of time to improve your score if you're a student. I have students who've been working practice questions and making mistakes, and like Josh says, getting a little bit more than 50% correct. But if they can improve just a little bit, they're actually within striking distance of earning a 4. So it's only a little bit of improvement over just a little bit less than a 2-week period.
I think that's a good note to end things on. So if you guys do have any more questions that you think of after you're watching the recording, please feel free to just send me an email and I can forward it along. We really appreciate you guys giving up your Wednesday evening to join us for this webinar. And like I said, you will receive the recording by noon tomorrow. So thank you so much for joining and supporting us tonight.
And good luck to all your students 2 weeks from today.
Yes, tell your students good luck.
Thanks a lot, Nicole.
Have a good night, everybody.
Good night.
Good night. Bye.